So good afternoon, everybody. Before we start, please let me introduce myself. My name is Diego. I'm a member of the new NLX software development team, and I'm in charge for designing and implementing the network automation platform of the company. And yes, today we are here to talk about peering networks and automatic bird configuration. So, as probably most of you know, using a route server is pretty common practice in implementing a peering network and to manage it, but unfortunately at the moment we can say that it's coming with a few severe limitations that are not really encouraging organizations in joining route server projects. With this limitation, within this limitation, I think the most, let's say, dramatic one is the fact that when you're joining a route server, you're just going to exchange your traffic with everybody in the same way. There is no real possibility to easily filter out who you want to peer, who you want to peer not. There are some techniques. You can use community strings, but these are pretty limited and also not really handy to be used. On the side of it, also the perception that organization has of the route server is pretty, they have the feeling it's kind of a black box. At least this is my experience. They don't really know what's happening inside it, and this is pretty scaring for them. And plus, at the moment, you can use script, you can do some stuff automatically, but mainly the route server is manually managed, and manually means time-consuming and error-prone. And that's not really what you want for your network. On top of it, in case you have a distributed network, like for example NLX has, also latency becomes a key factor in the selection of your peers, because if I'm connecting in London, I may want to peer with somebody close to me and not with somebody far away latency-wise. So as NLX, a few months ago, we decided to tackle this limitation and come out with the automatic solution that first of all needed to be flexible in terms of the possibility of selection of selecting your peers. It has to be completely automated, and being completely automated, and with the fact that we are removing the human factor from the configuration workflow and essentially exposing a web front end on the internet, needs to be, first of all, easy to use. You don't want to make courses about how to use your tool. It needs to be secure, because you don't want people, just some malicious people playing around in your network. It has to be fault tolerant. That means it has to be resilient to configuration error, because you always want your network to be up. And it needs to be feedback rich. With feedback rich, I mean that the system always needs to keep updated, system and the administrator and network engineer about what's happening on the network and what the automatic system is doing, especially in case something goes bad. In the end, it has to be easy to integrate as every automatic system. There is a configuration tool, has to be possible to easily integrate it in your automation platform, or to be controlled with automatic system. And actually we embraced all these challenges, and we came out with the NLX route configurator. I'm going to show it to you in a bit, but before I'd like to spend a couple of words about it, just to describe what it does. It's actually a web application that allows you to control your peering session via a user interface. So you offer full fine-grained control on your peers. With full fine-grained, I mean that you have the possibility to select your peers based on their specific IP, on their specific peering session. You can select your peers based on the location where they are connecting, or you can even select them by the latency from where they are connecting and where they are connecting. And the nice thing is that these three factors are not excluding each other, but they get combined. This means that you can decide to peer with everybody within 10 milliseconds, but not connecting in Amsterdam, and there are a couple of specific guys that for some reason you don't like, you can just filter them out. It supports filtering and prepending for the advertised prefixes. It's totally automated. It has a really nice web interface that I'm going to show you in a bit. And is designed modularly. With a modular design, I mean that each step It's atomic, it can be executed independently from the other ones. The different components are communicating via webhooks and REST API, so you can easily interact with each component of the automation platform you want, and even execute single steps or single portions of the complete automation chain. And we're using the tool live now since a few months. This feature has been particularly appreciated by our Neto engineers. And in the end, it's 100% open source. I mean, it's completely based on open source technology. So I'm going to show you now how this is working. Nope. Yep. I was supposed to have a live demo, but it was not really possible, so I prepared a small video. I'm going to talk over it to explain to you. So you can start. As you can see on the left part, you have the interactive map with all the locations where actually you can connect to our peering network. On the right part, you have the full list of all the members and their peering session identified with IP, AS number, name. And at the moment they are all selected, that's the base starting situation. So let's see you are a customer from NerdNet. You have a peering port in Amsterdam, so you select it, and you want to peer with everybody who's really close to you. So you slide back using the slider. Now it's 20, I think. You slide back to 2 milliseconds, and you can see the location getting unselected, and all the peering sessions that are in location more far away than 2 milliseconds just getting unselected automatically. And that's pretty nice. Now you're not peering anymore with these guys. You're just filtering them. Then you realize that from your selection, a couple of locations that you want has been filtered out. So you want to reselect London, and you want to re-add Brussels, because you can have some interest in peering there. And you can see the session gets selected again, in this case the one in Brussels. And then you make a full review of your list. You spot the guy that you don't want to peer with, you just unselect it. After it, you are essentially done. The only things you need to do is to apply the configuration. You click on the button. You can see you get a dialog box, and after you get the confirmation token by email. You fill it in the dialog box, and after it, your configuration gets automatically deployed on the route server within a couple of seconds. And I think it's pretty nice. It's a big step ahead of what's happening at the moment. But let's go to how this is implemented. Then maybe it's more interesting for you. Let's suppose that each of the the hexagons you should see, is a specific part of your automation platform. You obviously, starting from the UI. The UI, there is not so much to say about it. It's just a JavaScript UI implemented using React. You make your selection. Once you confirm, the data gets sent to a REST API server that is actually implemented using Django and using Django REST framework and the Postgres backend database. The data gets saved. There is not so much to say about it. It's really straightforward. What's interesting is what's happening after. Once the peering data they get saved, a signal is actually triggered against our automation orchestrator that is realized using a software called Stackstorm. This software catches the signal, it realizes there are new configuration data, so it fetches the new data from the REST API server, it builds a new valid bird configuration file, it automatically sends it to the route server for deployment. So you have the full chain, you can see. You have UI, send the data are saved, the signal is triggered, generation of the file, and automatic deployment. In detail, I will skip UI REST API server because there is a bit off topic and there is not so much to say about it. Let's go to our automation orchestrator that, as I said, is realized with Stackstorm. I don't know if here somebody is familiar with it. Does somebody knows? Just a few of you, I thought more. Anyway, for who doesn't know, Stackstorm is a generic automation product by Brocade. It's been bought by Brocade a few months ago, and they are actually implementing automation packs to interact with their boxes. So that was a good point, and we actually choose it for several reasons, mainly for how it's made and what you can do with it. What I mean, first of all, it runs on Linux, is implemented in Python, and is really easy to implement on top of it with Python. It's actually the reference language. And these are technologies that we really like in NLX. We are widely using them, so for us, we're just a perfect fit. But more important than our specific taste is what you can do with it. So it essentially allows you to define actions that are what need to be performed, are essentially functions. So you can define what needs to be performed, you can define in which condition these actions need to be performed, and these are the rules, and then you can create pretty complex workflows, simply stitching together different actions. And that's, in terms of automation, is pretty nice also because you can define everything using YAML, and it's really, really handy and quick. You can implement a new workflow in minutes. And another nice thing about this software is that everything gets executed, gets nicely tracked, and is easily accessible, not just via the log file, but you can open the interface, you have the full execution history of all the tasks for which you can check the outcome, what was the input, what was the output, access to all the internals. And that is pretty handy, especially when something goes bad. Our NOC team, they can just log on the Stackstorm and check. They check for the red bullets, and it's easy to understand what's going on. The software usually came packaged in plugins that they work on top of the Stackstorm platform. These plugins are usually called automation packs, and are just folders, so you can define it in the way you want. You can have a pack for interact with a specific software, as you can have a pack that you call for like context-based. You call network management pack, you put in it whatever you want. A lot of packs are already available, except for the lot of widely used software. Like, for example, in NLX, we are using the Slack pack, already made by Slack, to send us messages when something happens. So every time somebody makes a new route server configuration, I got a message on my phone, and I can check what's going on. And, or if you don't find what you're looking for already made, you can, you need to implement something by yourself. And this is actually what we did with Bird. We implemented the Bird automation pack called Bird. And the nice thing is a completely generic pack. I really want to highlight there is nothing really NLX related with it. It has a specific format. If you use that format, it's just going to work. And it's a pack for actually controlling Bird. It exposes two actions, one for generating a file and one for deploying it. And the workflow that stitches these two actions together. So you can first generate a file, and then you automatically deploy the file you generated. The generation is actually working the way I tried to summarize in this schema. You got two kinds of data as an input. You have the user input, that in our case is coming from the user interface, but you can type it in, or you can send it via an HTTP post. Until it's in the right format, in the format we defined, it's correct. And this is containing your peer selections, so the details about your peering sessions. And then you have the static data that are stored in the Stackstorm pack configuration file. Just I open a parenthesis. There is a Stackstorm for each pack allows you to define a configuration file where you can define all the parameters and all the values you may want to use in your action. In this case, we are using this file to store all the static data about our peering network, like IP of the route server, name of the network, peering prefix, your AS number, all this kind of information. On the side of these two different kinds of data, there is the template. The template is something usually a network engineer should write. Is the real template of the file that will be generated. It's a Jinja2-based template, and the nice thing is that it's extremely flexible. With this I mean that you can define all the parameters you want in the configuration file, and use this parameter as a placeholder in the template. So in the configuration file, I just write down the parameter called network name. In my template, I made network name parameter, and this gets replaced. These three different kinds of data, they go into the generation algorithm that as an output, it generates a configuration file for Bird. It can be IPv4 or IPv6, according to the user input, and it gets stored locally. It's nice to highlight that this is just atomic. You can just decide to use the Stackstorm pack to generate your file. You got data as an input, as an output, you get the file locally stored on the machine. In case you also want to deploy that file, there is a second action. It's called deploy config. Deploy config, what actually does, it takes a file that is locally stored on the Stackstorm machine. That's the only requirements. The file can be generated outside, you can write it by hand, you can generate it using the Stackstorm pack. The only important thing is that it's on the machine. You give it to the action the file name as an input, and what it does is simply send it to the route server. The route server validates it. If the validation is okay, he actually deploys it, and when the operation is done, he returns a message back to the Stackstorm orchestrator communicating the outcome, if it was good or not. If it was not good, our system is sending a message on Slack like, guys, something went bad in the deployment. How this transfer happening? Is happening over HTTP, assuming that you have your Stackstorm orchestrator running on a different machine on the route server. That is something I assume. If some of you is familiar with Bird, I don't know. This transfer happening by HTTP should sound pretty strange because, as you probably know, to run command of Bird, you should use the Bird console. It actually works on Unix socket, so you cannot really execute commands remotely. You need to log in on the machine and perform your operation. So, how this is possible? This is possible thanks to bird-proxy. Bird-proxy is a web application we wrote. It's really a tiny Python Flask application from which you can essentially control your bird route server simply by HTTP. He exposes endpoints. These endpoints are connected to functions that, using a library we wrote in-house, he runs commands on Bird. So we wrote this tiny library that it binds to the socket. You can execute all the legal Bird commands. So it's pretty handy. In our case, we just have an endpoint for the configuration for the deployment of a file, but you can implement endpoints for whatever you want. So get status information, get peering session data. And that's bird-proxy. You install it there, and it just works. From the technical point of view, that was it from me. I had to rush a bit because it's kind of a lot of stuff to say. I just have two things to add. First of all, this software is already live. It's already available for all the NLA Experience members. So if you're already a peer or if you are new, you can just contact us, you get your credential and start using it. And also really important is that in a few weeks, we are willing to release all the code as open source. And I personally hope that we will have a lot of contribution and a lot of people that are willing to help us in making this automation platform better. That was it from me. If somebody has some extra question, can always drop me an email on my personal email address, or some more generic question about our peering on our things as an LAX. There's a generic email address. Or you can always catch me after this talk or tonight at the social. That's it for me. Thank you for your attention. Any question?
Diego, thank you very much. And Andy Davidson's hand shot up. So let's get a mic to Andy.
Thank you. I enjoyed that presentation. I think that it's really interesting to see the amount of engineering that's gone into making this a robust platform for making very quick changes through to the root server. And I think it's a really good example of template-based configuration and orchestration. It was really, really good. For the last 4 meetings where this has been a topic that's come up, what on earth do we do about this remote peering stuff to make the internet useful again? I've always felt it's important for me to grab the microphone and apologise for my part in selling this awful remote peering stuff, and apologise to you for having to make these latency sensitive tools that allow people to sidestep the nasty quagmire that we're making with this dreadful product. So again, everybody, very sorry. But maybe some people will see the benefits of engineering routing close to where their router ports are as a result of the tools like this latency-sensitive root server configurator, and we can get back to having an internet that's built the way it should be again. Thank you.
Thanks.
But thank you for your atonement, Andy. And are there any other questions? I'll just come to Daniel in just a second, because I've actually got a follow-on comment from that. Me with my content, put my day job hat on for a minute, content distribution network, and one of the big problems that we had with remote peering, particularly people asking why we wouldn't peer on root servers, was because of the level of pollution of distance peers, which gives us, this is just to give some context of why it's really useful to a network. The level of distance peers that were present on root servers was like a pollution. And it means that, normally the simplest way of doing like closest node detection is to use Anycast routing for the DNS. That's normally a very easy way of saying, well, where am I going to serve anything? Well, I'll announce my DNS over Anycast, and if the DNS request has hit this node, then we can generally say it's good to serve out of that node. And trying to explain this to people has actually been quite a challenge. So it's actually really good to have this usability like that. And we have been asking other exchanges with the day job hat, and we have asked other exchanges, is there a way where we don't have the ability to say, I'm only interested in these peers, or I'm only interested in this, or I'm only interested in that? Is there a way instead for them to, for instance, tag peers peers that were learnt from a distance peer, routes from a distance peer with the community? Then we could at least just not accept them, just as an example. And then Mike to Daniel for a question, please. Just here.
Daniel from EXA. It's kind of technical questions about how actually you measure the latency. Is it just the latency, inter-pop latency, or are you actually trying to measure latency from the route server to the actually to the peer, using a kind of latency on the TCP session between on the BGP session or something else?
The latency is measured on the peer, but then we fill the table. So the latency is we took the latest one, the lowest one, taking from a table with all the measurement, and they are linked to the location. So they are not like peer-based, but we have all the measurement from distance to location, like Amsterdam to London, Amsterdam to, and the peers are linked to the location and to the data center, so we make our selection in that way.
Okay, that's.
Any other questions? Thanks very much, Diego. Really interesting. Thank you.
Thanks a lot.